In question 1, we have to solve the equation 3x plus 2 equals to 2 upon x minus 1. So this is a very basic equation, and we just have to cross multiply and solve it by factorization or using the quadratic formula. Cross multiplying, we'll get 3x plus 2 multiplied by x minus 1 equals to 2. Opening the bracket, we'll get 3x squared minus 3x plus 2x minus 2 equals to 2. Bringing the 2 on this side, we'll get 3x squared minus x minus 4 equals to 0. So using our calculators to solve this equation, or we can use middle term breaking as well, which will become 3x squared minus 4x plus 3x minus 4 equals to 0. Taking x common, this will be 3x minus 4, plus taking 1 common, this will be 3x minus 4 over here. Taking common 3x minus 4, we'll get 3x minus 4 into x plus 1 equals to 0. So 3x minus 4 will be equals to 0, and x plus 1 will also be equals to 0. One of the values of x will be 4 upon 3, and the other value of x will be equals to minus 1. In question 2, the equation of a curve is such that the d by dx is 12 into half x minus 1 to the power minus 4. It is given that the curve passes through P 6, 4. In part A, we have to find the equation of the tangent to the curve at P. So to find the equation of the tangent, we need the gradient. So to find the gradient of a tangent, it is given by finding the dy dx at the particular point. In this case, the point is P and the x-coordinate is 6. So to find the gradient of the tangent, in place of x, we'll substitute x equals to 6. So this will be half into 6 minus 1 to the power minus 4. This will become half into 6 upon 2 is 3. 3 minus 1 to the power minus 4. We can simplify to write it as 12 upon 2 to the power plus 4. So the gradient will be 12 upon 2 to the power 4, which is 16. Simplifying this will become 3 upon 4. So the gradient of the tangent will be equals to 3 upon 4. To form the equation, we'll use the formula y minus y1. So y minus y1 is 4 is equals to m into x minus x1. And the value of x is 6. Cross multiplying, we'll get 4y minus 16 is equals to 3x minus 18. We can simplify this to write it as 4y is equals to 3x minus 18 plus 16, which will be equals to, so minus 18 plus 16 will be equals to minus 2. In part B, we have to find the equation of the curve. Now to find the equation of a curve, we'll have to integrate the given equation. So before integrating, we'll write it as dy is equals to 12 into 1 upon 2x minus 1 to the power minus 4, and we'll bring the dx on this side. Now putting the integration sign, so integrating dy, that will become y is equals to 12 into 1 upon 2x minus 1. Increasing minus 4 by 1, that will become a minus 3. We'll divide by minus 3 and also multiplied by the derivative of half x minus 1, which will be 1 upon 2. And we'll add a plus c. Now to find the value of c, we'll substitute the values of x and y. So they were 6, 4. So in place of y, we'll put 4 is equals to 12 into half into 6 minus 1 to the power minus 3. And this is being divided by minus 3 upon 2 plus c. So 2 will come into the numerator. So that will become 4 is equals to 24 upon minus 3. And we can bring this 3 minus 1, which is 2. So we can make it positive, the power positive, by bringing the 2 in the denominator. So this will be 2 cubed plus c. Simplifying this, we'll get 4 is equals to 24 divided by minus 3 multiplied by 8, which is also minus 24. 24 divided by minus 24 will be minus 1. So c will be equals to 4 plus 1, which is equals to 5. So we can write our equation as y is equals to, so that became 24 upon minus 3, which will become, so 24 upon minus 3 is minus 8 into half x minus 1 to the power minus 3 plus 5. In question 3, a curve has equation y equals to ax power half minus 2x. The curve has a stationary point at the point P, which has x coordinate 9. We have to find the y coordinate of P. To find the y coordinate, first we'll have to find the value of a and then substitute the x coordinate to find the value of y. So the stationary point basically means that the dy dx will be equals to 0. In the first step, we'll find an expression for dy dx. So that dy dx will be equals to 1 upon 2 times a, and the power will decrease by 1, which will become minus 1 upon 2. Differentiating 2x, that will become a 2. And now the x coordinate is 9 and dy dx is equals to 0. So we can write it as 0 is equals to 1 upon 2a into 9 to the power minus 1 upon 2 minus 2. Taking the 2 on the other side, that will become 2 is equals to, so we can write it as a upon 2 into 9 to the power 1 upon 2. 9 to the power 1 upon 2 is 3. 3 times 2 is 6. And 6 times 2 will become a 12. So now we have the value of a as equals to 12. We can write the equation as y equals to 12 x to the power 1 upon 2 minus 2x. Then the value of x was equals to 9. So to find the y coordinate, we'll write 12 into 9 to the power 1 upon 2 minus 2 into 9. So 12 into 9 to the power 1 upon 2, that is 12 times 3, which is 36 minus 18. So the y coordinate will be equals to 18. In question 4, the coefficient of x square in the expansion of 1 plus 2 upon px to the power 5 plus 1 plus px to the power 6 is 70. We have to find the possible values of the constant p. Now, to find the value of the constant p, we'll first find the x squared terms in both the expression and then add them up to put them equals to 70. Now, if you have an expression of the form 1 plus b to the power n, the formula is 1 plus nc1 b power 1 plus nc2 b power 2 and so on. Now, in both the cases, we have, in place of b, we have an x term. So to get an x squared term, we'll be using nc2 b to the power 2. So using the for the first expression, which is 1 plus 2 upon p power x to the power 5, we'll write 5c2 b to the power 2. So b is 2 upon px to the power 2. So 5c2 is 10. So this will be 10 into 4x squared upon p squared. So we can say that the coefficient of x squared in this case will be 40 upon p squared. For the second expression, which is 1 plus px to the power 6, this will become 6c2 px to the power 2. 6c2 is 15, so this will be 15 p squared x squared, and the coefficient of x squared will become 15 p squared. Now, as the sum of the coefficients of x squared will be equals to 70, so we'll write 40 upon p squared plus 15p squared equals to 70. Now, taking the LCM, the LCM will be p squared, so this will become p squared. So this will be 40 plus 15 into p squared will become 15p to the power 4 equals to 70. Simplifying this, we'll write it as 15p4 plus 40 is equals to 70p squared. Bring the 17p squared on the left hand side, this will become 15p power 4 minus 70p squared plus 40 equals to 0. Now dividing the equation by 5 to make it simpler, we can write this as, so 15 divided by 5 will be 3p power 4 minus 14p squared plus 8 equals to 0. Now, as we have a expression to the power 4, we can use a substitution. So we can write x is equals to p squared and x squared will be equals to p to the power 4. So this expression will become 3x squared minus 14p, 14x. So this will become 14x plus 8. Using our calculators to find the value of x or using middle term breaking. So this is 3 times 8 is 24. So we'll be using 12 and 2. So this will be minus 12x minus 2x plus 8 equals to 0. Taking 3x common, we'll get x minus 4. And from here, taking 2 common, we'll get x minus 4. Simplifying, this will be x minus 2, 3x minus 2, and x minus 4 equals to 0. So the two values of x will be x equals to positive 4 and x equals to 2 upon 3. Now, as the expression was x equals to p squared, using the first value of x, which is 4, so this will be 4 is equals to p squared. Taking the square root of 4, we'll get p equals to plus minus 2. And now taking the second value of x, which is 2 upon 3. So this will become 2 upon 3 equals to p squared. So p will be equals to the square root of 2 upon 3. So we can write the answer as p will be equals to plus minus the square root of 2 upon 3. In question 5, the diagram shows a sector OAB of a circle with center O. The length of the arc AB is 8. It is given that the perimeter of the sector is 20. We have to find the area, find the perimeter of the shaded segment. Now the shaded segment consists of the length AB and the arc AB. To find the length of AB, as we know that the total perimeter is 20, and these two are both equal in length. So we can say that 2r plus 8 will be equals to 8, will be equals to 20. So 2r will be equals to 12 and r will be equals to 12 upon 2, which is 6. Now to find this angle theta, that we know that the arc length formula is s equals to r theta. The arc length is 8 and the radius is 6 multiplied by theta. So theta will be equals to 8 upon 6 or 4 upon 3. Now once we have this angle as 4 upon 3 radians, we can find this length using the cosine rule. So we can say that AB squared will be is equals to 6 squared plus 6 squared minus 2. So that will be 2 into 6 cos of 4 upon 3. Substituting this value into the calculator, the value of AB will be is equals to, so substituting this in the calculator and taking the square root, this will be equals to 7.42 centimeters. So the total perimeter will be equals to the arc length, which is 8, plus 7.42, which will be equals to 15.42 centimeters. As we have to give our answer in 3 significant figures, so we'll give our answer as 15.4 centimeters for the perimeter of the shaded segment. In part B, we have to find the area of the shaded segment. Now to find the area, we will first find the area of the sector and then subtract the area of the triangle. So the area of sector is given by the formula half r squared theta. So the area of sector is 1 upon 2 into r squared into theta. So this will be 1 upon 2 into 6 squared into 4 upon 3. Simplifying this will become 36 into 4 into divided by 2 into 3. We can simplify this to write it as, so this area will be equals to 24 centimeters squared. Now the area of the triangle, we can use the formula half AB sine C. So using the formula half AB sine C, as both the lengths are equal, so this will become half into 6 into angle sine. So the angle between them is sine of 4 upon 3. Substituting this value in the calculator, the area of the triangle will be 17.49 centimeters squared. And finally, the area of the shaded region will be is equals to 24 minus 17.49. So the final answer will be, so subtracting 24 and 17.49, the answer will be 6.5 centimeters squared for the shaded region. In question 6, we have to first show that the equation 1 upon sine plus 1 upon sine minus cos equals to 1 can be expressed in the form a sine square plus b sine plus c equals to 0. So in the first step, we'll first take the LCM. The LCM will become sine plus cos and sine minus cos. This one will multiply by sine minus cos, and this one will multiply by sine plus cos equals to 1. Minus cos and cos will cancel, so this will be sine plus sine, which is 2 sine. Sine plus cos and sine minus cos will multiply by 1, so it will remain as it is. We can simplify this using the expression a minus b, a plus b, which is equals to a squared minus b squared. So we can write this as sine squared minus cos squared equals to 2 sine. Using the identity, sine squared plus cos squared equals to 1. So cos squared will be equals to 1 minus sine squared, as we have to bring our expression in terms of sine. So this will be 2 sine is equals to sine squared minus 1 minus sine squared. Expanding this, we'll get sine squared minus 1 plus sine squared equals to 2 sine. So this will become 2 sine squared. Bring the 2 sine on the right hand side. This will be minus 2 sine minus 1 equals to 0. So the values of A will be 2, B will be -2, and C will be -1. In part B, we have to solve the equation, the same expression for 0 to 360. So the expression was 2 sine squared minus 2 sine minus 1 equals to 0. We can solve this using the quadratic formula. So for quadratic formula, it is minus b. So this will be minus 2 plus minus b squared. So that will be minus 2 whole squared minus 4 into a into c, which is -1, divided by 2 into 2, which is 4. So sine theta will be equals to 2 plus minus square root of, this will become 4 plus 8, which is 12 upon 4. Now we can write sine theta as 2 plus square root of 12 upon 4 and sine theta as 2 minus square root of 12 upon 4. Now, as this answer will be greater than 1, so we will reject this answer. And now taking sine inverse of 2 minus square root of 12, so that we will get 2 minus square root of 12 divided by 4. And then taking shift sine inverse of the answer, we'll get the basic angle is 21.5 degrees. So once the basic angle is 21.5 degrees, and as theta was negative up here, so we'll take sine in the negative quadrants, so making 21.5 in the third quadrant and 21.5 in the fourth quadrant. The angle for sine will be 180 plus 21.5. So theta will be equals to 180 plus 21.5, and this will be 360 minus 21.5. As this value was a negative, so we'll be getting the theta in the negative quadrants of theta of sine. So theta will be equals to 201.5, and 360 minus 21.5 will be 338.5 degrees. In question 7, a tool for putting fences posts into the ground is called a post hammer. The distance in millimeter that the post sinks into the ground on each impact of the post hammer follows a geometric progression. The first three impact causes the post to sink into the ground by 50, 40, and 32 millimeters respectively. In part A, we have to verify that the ninth impact is the first in which the post sinks less than 10 millimeters into the ground. Now, as it is a geometric progression, the nth term for a geometric progression is given by a r to the power n minus 1. As a is 50 over here, and to find r, we divide two consecutive terms. So r will be the second term divided by the first term, which will be equals to 4 upon 5. So the nth term formula will be equals to, as the first term is 50, so 50 into 4 upon 5 to the power n minus 1. As we have to verify for the ninth impact, it means we are finding the ninth term. So this will become n9 is equals to 50 into 4 upon 5 into 9 minus 1. So this will become 50 into 4 upon 5 to the power 8. Substituting this value into the calculator, this will come out to be 8.39. So basically, we wanted to verify that this is the ninth impact is the first in which the post sinks less than 10 millimeters into the ground. So this is less than 10. However, just to verify, let's first find the eighth term. So the eighth term should be greater than 8.39. So for the eighth term, we will write 50 into 4 upon 5 into 8 minus 1. So this will become, the eighth term will be 50 into 4 upon 5 to the power 7. Substituting this in the calculator, we will get this value as 10.5. As this is greater than 10, it means that the ninth term is the first in which the post will sink less than 10 millimeters. In part B, we have to find the total depth of the post in the ground after 20 impacts. So as it is talking about the total depth, it means we'll have to apply the sum formula, which is a into 1 minus r to the power n upon 1 minus r. In this case, a is 50, so this will be 50 into 1 minus 0.8. R was 4 upon 5, which is 0.8. And as we are finding for the 20 impacts, so this will be 20 divided by 1 minus 0.8. Substituting this in the calculator, the sum for the total depth after 20 impacts will be equals to 247. In part C, it is asking us to find the greatest total depth in the ground which could theoretically be achieved. Now, as in this progression, R is less than 1, and it is talking about the greatest total depth, it means, for example, if we have n as, let's say, if we keep on increasing the value of to 10, 100, 1,000, and so on, what could be the greatest total depth? It means we are talking about the sum to infinity. Now, the sum to infinity formula is a upon 1 minus r. And if you look at the sum formula, which is a into 1 minus r to the power n divided by 1 minus r, as r is 0.8, as we keep on increasing the power, this number will keep on decreasing. And for a very high value of n, this will nearly be 0. So that's why it will be taken as a upon 1 minus r. Now, a is 50. We'll divide by 1 minus 0.8. So 50 divided by 0.2 will be equals to 250. So 250 millimeters is the greatest depth in the ground which could theoretically be achieved. In question 8, the function f is defined by f of x equals to 2 minus 3 upon 4x minus p, where p is a constant. In part A, we have to find f dash of x, which basically means the derivative of f of x, and then hence we determine whether f is an increasing function, a decreasing function, or neither. In the first step, before differentiating, we'll bring the 4x minus p in the numerator. So this will become 2 minus 3 into 4x minus p to the power minus 1. Differentiating f of x, so the derivative of 2 is 0. Minus 1 into minus 3 will become a plus 3 into 4x minus p. The power will decrease by 1 to make it a minus 2. And we also multiplied by the derivative of 4x minus p, which is 4. Simplifying this will become 12 upon 4x minus p whole squared. Now, as we have positive 12 in the numerator and 4x minus p whole squared, it will always be positive for all the values of x. So it will write it as 4x minus p is 4x minus p whole squared is always positive for all values of x. This means that f dash of x will be an increasing function, as it will always be greater than 0. In part B, we have to express f inverse of x in the form p upon a minus b upon cx minus d. So f of x was given as 2 minus 3. So this was 2 minus 3 upon 4x minus p. To find inverse, first we write y in place of f of x. So this will be y equals to 2 minus 3 upon 4x minus p. Now exchanging the values of x and y, this will become x equals to 2 minus 3 upon 4y minus p. Now to bring it into this particular form, we can first bring the 3 upon 4y minus p on the other side. So this will become 3 upon 4y minus p, and this will be is equals to 2 minus x. Now, as the form said b upon cx minus d, so we'll bring the 2 minus x in the denominator of 3 and bring 4y minus p on the other side. So we can write this as 4y minus p will be equals to 3 upon 2 minus x. Now to make y the subject, first we'll bring the p on the other side. This will become p plus 3 upon 2 minus x. In the last step, we'll divide it by 4. So this will become p upon 4 plus 3 upon 4 into 2 minus x, as 4 will divide with both the denominators. So this is 4 into 2 minus x. Now, as the expression was p upon a minus b upon cx minus d, so as we have a plus sign over here, we can bring a minus by first expanding this. So this will become 3 upon 8 minus 4x. So let's say if I take negative common out from over here, we can write this as y equals to p upon 4. So as we took the negative out, we can write this as, in the first step, we can just write 3 upon, taking negative common out, this will become 4x minus 8, and then we can write the negative sign up here. So the final expression will be f inverse of x will be equals to p upon 4 minus 3 upon 4x minus 8. In part C, it is asking, hence state the value of p for which f inverse of x is basically identical to f of x. Now, f of x was, if you look at the expression f of x, it was 2 minus 3 upon 4x minus p. Now, in place of p over here, we have an 8. So if I put an 8 up here, 8 upon 4 will become a 2. So we'll say that for p equals to 8, f inverse of x will be identical or an identity of f of x. In question 9, functions f and g are both defined for x as an element of real number and are given by f of x equals to 4x squared minus 4x plus 9. G of x is 2x squared plus 4x plus 12. In part A, we have to express f of x in the form x minus a whole squared plus b. So for f of x to convert it to x minus a whole squared plus b, this is the full square form. So when we are completing the square, first we add half b to the equation. So this will become x squared minus 4x plus 2 squared. And as we have added 2 squared over here, so we'll subtract 2 squared as well, plus 9. So this will become x squared minus 4x plus 4 becomes x minus 2 whole squared. And minus 4 plus 9 will become a plus 5. So the values of a will be 2 and positive 5 for b. In part B, we have to express g of x in the form 2 into x plus c whole squared plus d. In this case, we will use the comparison method. So g of x was 2x squared plus 4x plus 12. Now we can still use the completing the square form up here, but as we have already done completing the square method in the first part, so we'll use comparison method to convert g of x in this particular form. So now taking 2 common from g of x, this will become x squared plus 2x plus 6. And as we have to convert it to the form x plus c whole squared plus d. So expanding x plus c whole squared, that will become x squared plus 2xc plus c squared plus d. Now comparing, so the coefficient of x is 2c and over here is 2. So we can say that 2c is equals to 2 and c equals to 1. The constant, which is c squared plus d, over here will be equals to plus 6 up here. So this will be equals to plus 6. Now as c is 1, so this will become 1 squared plus d equals to 6 and d will be equals to 5. So we can write a final answer as g of x will be equals to 2 into bracket. So c is equals to 1. So we'll write x plus 1 whole squared and d is 5. So this will be plus 5. In part C, we have to express g of x in the form k f of x plus h. Now f of x was x minus 2 whole squared plus 5. So first let's write f of x was equals to x minus 2 whole squared plus 5. And g of x, we converted it to the form. So g of x was 2 bracket of x plus 1 whole squared plus 5. So if you have to express g of x in the form kf of x plus h, it means we have to multiply the function f with a constant k and add a value of h up here to make it equals to g of x. So in the first step, what we'll do is we can multiply this whole function by 2. So we can write this as 2 into x minus 2 whole squared plus 5. Now the difference between g of x and this function is that there's a plus 1 up here. And as we have to add a value up here, so to make minus 2 to a plus 1, so we'll have to add a 3. So this means we'll have to write this as x plus 3 minus 2 whole squared plus 5. So this will become 2 into x plus 1 whole squared plus 5, which was the expression for g of x. So we can say that in this case, the value of k will be equals to 2. And as we added 3 up here, so we added 3 to h, 3 to x, it means that the value of h will be equals to 3. In part D, we have to describe the two transformations that have been combined to transform the graph of f of x to the graph of g of x. Now we had f of x, which was equals to So f of x was x minus 2 whole squared plus 5. So we multiplied the function by 2, which means that there was a stretch in the y direction first, as we have multiplied the whole function by 2. So this will be a stretch in the y direction, and the scale factor will be equals to 2. And as we added 3 to h, it means that there was a translation, and the translation vector will be 3 and 0, as the graph was only moved positive 3 units in the x-axis. In question 10, curves with equations y equals to 2x power half plus 1 and y equals to half x squared minus x plus 1 intersect at A and B as shown. In part A, we have to find the area of the region between the two curves. Now, to find the area of the region between the two curves, first we'll find the area under the curve with the equation y equals to 2x power half plus 1. Then find the area below the curve for which the equation is y equals to half x squared minus x plus 1, and then subtract the two areas. So area in this case will be equals to, in this case, the limits will now be 4 and 0. So this will be 4 and 0. The equation for the curve, which upper curve is 2x into power 1 upon 2 plus 1, and we subtracted from the curve with the equation half x squared minus x plus 1. So integrating 2x to the power half, that will become 2x to the power 3 upon 2 divided by 3 upon 2 plus 1, and integrating 1 will become x. And in the second case, integrating x square will become x cube and will divide by the new power. So dividing by 3 will become 3 times 2, 6, minus integrating x, that will become x squared upon 2, and integrating 1, that will become nx. And this is a 2 up here. Now substituting the limits 4 and 0 in both the cases. So substituting 4 up here, this will become 2 into 4 to the power 3 upon 2 divided by, so this 3 will remain the denominator and this 2 will multiply. So this will be 2 times 2 plus x. So x is 4. And if we substitute x equals to 0 in both of the terms, they will become a 0. So we leave it as it is. Now we'll substitute x equals to 4 into this expression. So this will become 4 cube 64 upon 6 minus 4 square, which is 16 upon 2 plus 4. So 4 to the power 2 or 3 upon 2 becomes an 8, and 8 times 4 will become 32. So this will be 32 upon 3 plus 4 minus 64 upon 6. So this will be minus 64 upon 6, minus minus will make it a plus, and 16 upon 2 is 8, and minus plus is minus, so this will be a minus 4. Simplifying 64 upon 6, that will become 32 upon 3. So 32 upon 3 and minus 32 upon 3 will cancel out. Similarly, 4 and minus 4 will also cancel out. So the final answer for the area between the two curves will be equals to 8. In part B, the acute angle between the two tangents is denoted by alpha. So we have to find the value of alpha. Now, to understand how to find the value between these two tangents, what we must understand is that if a line has a gradient of, let's say, 2, so if the gradient is 2, it means that the y value is 2 and the x value is 1, as gradient is given by y over x, or change of y over change of x. Now, to find the angle it makes with the horizontal line, we can use, if let's say if this angle is alpha, so we can use tan alpha will be equals to opposite over adjacent. So we'll use 2 upon 1 and tan inverse of 2 upon 1 to find the value of alpha. Now, as we have two tangents up here, if we make a horizontal line, first we'll find the angle made by this tangent and then the angle made by this tangent, and then subtract the two angles to find the angle in between. So the two equations that we had for the curves were, so this was y equals to half x squared minus x plus 1. Finding the gradient for the tangent, so this curve represents this tangent. So first we'll find the angle made by this tangent and then find the angle made by the tangent to the curve 2x power half plus 1. And then once we have these two angles that they make with the horizontal, we'll subtract them to find the angle alpha. So the other equation is y equals to 2x to the power 1 upon 2 plus 1. First, finding the dy dx, as it will give us the gradient. So dy dx in this case will be 2x upon 2, which will be x, minus, in this case, differentiating x will become 1. And differentiating 1, it becomes a 0. Differentiating the second equation, so multiplying 1 upon 2 by 2, that will become a 1, and decreasing the power by 1. So this will be x to the power minus 1 upon 2 plus 0. And we can write it as 1 upon x to the power 1 upon 2. Now using x equals to 4 as they're intersecting at the point x equals to 4. So the gradient for the first equation will be equals to 4 minus 1, which will be equals to 3. And the gradient for the second tangent will be 1 upon square root of 4, which will be equals to 1 upon 2. Now to find the angle alpha, let's say this was the tangent with the gradient 3. So to find the angle it makes with the horizontal, we can say that this length will be 3 and this length will be 1. So we will use tan inverse of, so tan, let's say this was angle theta. So this will be tan theta will be equals to 3 upon 1. And we'll use tan inverse of 3 to find the angle theta. For the second line, for a second tangent, the gradient is 1 upon 2. So this will mean that this length is 1 and this length is 2, as this is opposite and this length is adjacent. So we'll use minus tan inverse of 1 upon 2 to find that this angle that this tangent makes with the horizontal. And once we find these angles, we'll subtract them to find the angle alpha. So tan inverse of 3 is 71.57. Minus tan inverse of 1 upon 2 is 26.57. Subtracting the two angles, the angle alpha will be equals to 45 degrees. In question 11, the diagram shows a circle with equation x squared plus y squared equals to 20. Tangents touching the circle at points B and C pass through the point A, which is 0, 10. In part A, by letting the equation of a tangent y equals to mx plus 10, we have to find the two possible values of m. Now, as we have an unknown constant over here, it means we'll have to apply the discriminant b squared minus 4ac. So substituting y equals to mx plus c in the equation of the circle. So this will become x squared plus, in place of y, we'll substitute mx plus 10 whole squared equals to 20. Now expanding the bracket, we will get x squared plus m squared x squared plus 20 mx plus 100. And then we'll bring the 20 on this side. So this will be 100 minus 20, 100 minus 20 equals to 0. Now taking x square common, we'll get 1 plus m square as a coefficient of x. X square, the coefficient of x is 20m, and the constant term will be 80. Applying b squared minus 4ac, and as the lines are a tangent, so it will be equals to 0. So b is 20m over here, so we'll write 20m whole squared minus 4 into a is 1 plus m squared times c is 80 equals to 0. Expanding 20m squared, that will become 400m squared minus 4 times 1 times 80 will be minus 320, and minus 4 times m squared times 80 will be minus 320m squared. 400m squared minus 320m squared is 80m squared, and we can bring the 320 on the other side. So m squared will be equals to 320 upon 80, which is equals to 4. So m will be equals to the square root of 4, which is equals to plus 2 and minus 2. In part B, we have to find the coordinates of B and C. Now, as we have the m values for the two tangents, one of them is plus 2 and the other is minus 2. So we can now solve the equation simultaneously. So this will become x squared plus, and in place of y over here, the equation of the tangent will be y equals to 2x plus 10. And the second equation will be y equals to minus 2x plus 10, as the values of m were 2 and minus 2. So in place of y, we can first substitute 2x plus 10 whole squared is equals to 20. Expanding this, we'll get x squared plus 4x squared. So 2 times 2, 4 times 10 will become 40x plus 100, and then we can bring the 20 on this side. So this will be minus 20 equals to 0. Simplifying this, we'll get 5x squared plus 40x plus 80 equals to 0. We can now use our calculators to find the value of x, or we can simplify this to first write it as x squared plus 8x plus 16. And factorizing this, we'll get x plus 4 and x plus 4 equals to 0. So the value of x will be equals to minus 4. Once we have the value of x, we can substitute this into the first equation where m was positive 2. So the value will be 2 into minus 4 plus 10. So y will be equals to minus 8 plus 10, which will be equals to positive 2. So the coordinate with the point which has x coordinate negative, which is b, so its coordinates will be minus 4 comma 2. And to find the coordinates of c, we'll substitute y equals to minus 2x plus 10 into the same equation. So when we do that, the equation will in this case now become, it will be x squared plus, so as it is minus 2x plus 10, we can write it as 10 minus 2x whole squared equals to 20. So this will be x squared plus 100 minus 40x plus 4x squared, and then we can bring the 20 on this side. This is not a 200, this is a 20. Simplifying, we'll get 5x squared minus 40x plus 80 equals to 0. Simplifying this, we'll get x squared minus 8x plus 16 equals to 0. So in this case, the factors will be x minus 4 and x minus 4 equals to 0. So the value of x will be positive 4. Once you have the value of x as 4, we can substitute it into this equation to get the coordinates of c. So y will be equals to minus 2 into positive 4 plus 10. So minus 8 plus 10 will again be a 2. So the coordinates of c now will become, so 4 comma 2, and the coordinates of b are minus 4 comma 2. In part C, it says that the point D is where the circle crosses the positive x-axis. We have to find angle BDC in degrees. Now, I have attached the diagram up here. Now, to understand how to find the angle BDC, first let's join the points to make a triangle BDC. So, B and C will be a straight line. As we already know that the coordinates of C are 4 comma 2, and the coordinates of B will be minus 4 comma 2. Joining B and D, and then finally joining C and D, will be able to form a triangle BCD. So once we have made this triangle, we need to find the angle BDC. So this angle is the unknown, let's call it theta. Now there are multiple ways we can approach this question. One of them is that if we can find this complete angle, so from CDO, if you find this angle and then subtract the angle BDO, we'll be able to find the angle in between. Now to find this angle, we know that D will have coordinates, so as y is equals to 0. So we can say that as y is equals to 0, so x square will be equals to 20 and x will be equals to square root of 20. So this point is square root of 20 and point C has coordinates 4. So to understand this, let's say if I make a line from C till the x-axis, we will have another triangle, and let's call this point as x. Now, if I draw the triangle CXD, so let's say this point is C, this point is D, and this point is X. If I want to find this complete angle theta from D till the x-axis, this is 2, and as from O till D, the total length is 4, and from O till X, the total from O till D, the total length is square root of 20, and from O till X, the total length will be 4, as the X coordinate of C is 4, and we have drawn a perpendicular line from C till X. So we can say as the total length is square root of 20 and OX is 4, so the length XD will be square root of 20 minus 4. Now taking tan inverse of 2 upon square root of 20 minus 4. So in the first part, we can find the angle CDO. So the angle CDO will be equals to tan inverse of 2 divided by square root of 20 minus 4, which is equals to 76.717 degrees. Now in the next part, we have to try and find the angle BDO. Now to find the angle BDO, let's make a triangle from BD and let's call this point as Y. Now we know that from O till D, the total length is square root of 20, and from O till Y, the length will be 4 as the x coordinate is 4 up here. This is 2. So we can say that to find the angle BDO, we can use tan inverse of 2 upon, and this total length, the adjacent length will be 4 plus square root of 20. So finding angle BDO, this will become equals to tan inverse of 2 upon 4 plus square root of 20. So finding 4 plus square root of 20, that will be equals to 13.282. And then the angle which we had to find BDC, as it is an angle in between. So BDC will be 76.717 minus 13.282. So 13.282, so 76.717 minus 13.282 will be equals to 63.435. So the angle BDC will be equals to 63.435. And as we have to give our answer in for angles to one decimal place, so the final answer will be 63.4 degrees. Now we can apply different methods to find this angle. Another one of the methods that we could have applied was that, let's say if I had drawn a line from B till C and another line from C till O, we would have to apply the circle property where it says that the angle at the center is twice the angle at the circumference. So to find this angle at the center, let's say if we can find this angle over here, BOA, and then we can multiply it by 2 to find the total angle BOC. So we already know that this total length was 10. We can find the length of BD through Pythagoras theorem over here, as this length is 2 and this length is 4. So we can apply Pythagoras theorem and find the length of OB. And as this is a right angle due to the tangent, we can apply adjacent over hypotenuse to find the length, to find the angle BOA. Once we find that angle, we can multiply that by 2. So we can just quickly do this over here just to see if we can apply different method to find the angle. So let's say this the length of OB will be equals to square root of 2 square plus 4 square. So that will be equals to square root of 20. Now finding this angle, so the adjacent angle to this angle is the adjacent length to this angle BOA will be square root of 20. So we can say that cos of BOA will be equals to square root of 20 divided by 10. Now finding cos inverse of, so cos inverse of square root of 20 divided by 10 will be equals to, so square root of 20 upon 10, that is equals to 63.43. Now, as this angle is 63.43, this angle will also be 63.43, and half of this angle will again be this angle, which is BDC. So the angle BDC will again be 63.43 degrees. So we can write this as 63.43 first in the first step. Then we can write angle BOC will be equals to 2 times 63.43. And finally, BDC will be equals to half of angle BOC. So the final answer will again be 63.4 degrees for angle BDC.